Let's see how we do with Algebra Half, Lesson 9. Points, rays, lines and line segments, angles, perimeter, pages 34 and 35. All right. Let me just grab a pen here. A point is a location in space. Point is a term you know. It's usually shown as a dot on a line. A point. It's a spot. It's an exact location in space. So we show them kind of like this. We label them with a letter. Okay. Curve is an endless connection of mathematical points. A line is what we call a straight curve. Okay. Line technically does not have width, but we can't show something that doesn't have width. So when we draw with a pencil, it usually looks something like that, and it's supposed to never end. It's just a length, and so to show that it never ends, we write arrows on both sides. It's very important to remember that, or technically you're breaking the rules of science. This shows, even though we can't show it really, that the line never ends. Right? How can I label a line? We'll add points to either side and label them with letters. Let's use AB. Okay, line AB. How do I write that? Like as in an answer? I put the letters AB next to each other, and I put a little miniature version of a line on top, and I read that as line AB. A ray is sometimes called a half line. A ray would be like if we had the same thing, but only one side goes on forever, the other side ends in a point. So actually maybe it would be better if I go all the way to there. Now I have ray AB shown like that, right? Simple enough. Now what about a line segment? What changes with a line segment? Does not go on forever. Therefore, it ends on both sides with a point. And I'll fix my B. How would I label or refer to what you see in front of you? I would go like that, and I would call it line segment AB. A line segment is a portion of a line. We had the line on either side, but this is just the portion. Segment AB does not go on forever. What if I told you AB was 3, and let's not get specific. Let's just say it's 3 units long. Okay? What if I said this line goes on further? I don't like how crooked that was. Line like so. And let's put another point here, A, B, C. And just for fun, let's say this is all on a line, but AB is still a segment. If AB is 3 units, what if I said AC were 7 units? How big is AB? Well, if all of this is 7, it's just a missing number problem for using subtraction. This is all 7 units. What's BC? BC is 4 units. Okay. An angle is something we form with 2 rays. Maybe you can already picture in your head a little bit what an angle looks like. An angle can look like this, maybe like this, right? And we label angles based on the measure of the vertex. The vertex is this little area here we show with like an arc. This is a 90-degree angle, I'm going to say. Even if you measured it, it probably isn't perfect. But that means it's perfectly perpendicular, and we call that a right angle. What about the vertex on this? Bigger or less than 90 degrees? This is going to be less than 90 degrees if you use a protractor. So this is an acute angle. And finally, what do we call one that's over 90 degrees? Obtuse. Okay. A straight angle is formed by putting two 90-degree angles together, and it ends up being, if you put two perpendicular together, that's straight, otherwise known as 180 degrees, otherwise pretty much a line, right? It's a straight line, putting those two together. All right. Perimeter comes from, well, a prefix meaning around, and we can measure perimeter just by adding up lengths of sides. So even if it's not a perfectly convex shape and I've got like a dent in here, as long as I know that this is 3 and this is 1 and this is 2 and this is 4, I can do perimeter with this, right? 5 plus 3 is 8, plus 11 is, or plus 3 is 11, 12, 14, 18 is my perimeter. Don't mix it up with area. Perimeter is the length of all the sides added up. Distance around. We can do it with circles, right? Call it circumference. We can do it with any shape that's a closed figure. A polygon, yeah, polygon has sides. Now what if you were taking out some of the measurements, okay? This is the last thing you need to be able to learn to do. Perimeter, when they don't give you all the measures. There's different strategies for accomplishing those things. You know, if I've got a shape like this, real funky looking, and I say this is 4, let's just say this is 2, even though it doesn't look like 2 at all, and I don't know what this is, but I know these are 6. Well, I'm not going to label that right now, but let's say 8, 14, 8. Okay, now I need to figure out what is x, and then what is the perimeter. All right, well, x we can actually find with some operation work, can't we? You might say there's no way to know what this is, but this adds up to the same thing as 1, 2, 3. Okay? Does that look right? It does. So therefore, 2 plus 4 plus x needs to equal 14, and it's that process of elimination that will always help you with these problems. So 6 plus x is 14. Therefore, x must be 14 minus 6 is 8. So this is 8. This is the same as this. So this is 6, and you just add all of these up. You're going to end up with 56. Don't forget, if it tells you what it's measured in, you include, you know, if this is feet, you include feet in your final answer. It's just addition and logic sometimes, figuring out what sides are. So you're going to get to practice that with letter D. All angles are right angles. Don't forget dimensions are centimeters. You need to solve for 2 missing sides, then add the distance around. And why don't you do letter B as well? So B and D. Practice problems before you begin the work. Thank you.